Alright, this is for Algebra 2, Semester 1. We are on Monday, July 7th. And we're going to cover sections 3.7 and 9.9. So we're going to start on page 138. I'll do a couple of them for you. You're going to be doing 1 through 9 odd. So I'm going to do 1 and 2, even though 2 is not one of the ones that has to be on your paper, but it would probably be a good idea to do that one as well. Number 1 says y minus 2 is greater than or equal to 0. Alright, this one has no x value. So we're just going to solve for y. We're going to add 2 to both sides. So you'll get y is greater than or equal to 2. So you're going to draw yourself a little x and y axis. Let me see if I can find one line. Okay, so draw a little x and y axis, and it's going to touch the y axis at 2. So if you go up to 2, you're going to have a point on the y-axis. Now, since there's no x, it's not going to touch the x-axis, so it's not coming down or curving or anything like that. It's not going to touch this x-axis. So what it essentially is, it's going to be a line straight across like this, horizontally, that never touches the x-axis. Now, it's a solid line because this little equal sign underneath, and greater than is telling me to shade the higher numbers. That's going to be all of these numbers up on top. So this is going to be your shaded area. It means any point up in here is going to have a y value that's greater than or equal to 2. Now let me do one that's got 2 variables instead of number 2, because number 2 only has 1 variable as well. You're going to do at least 1 through 9 odd, so I'm going to do number 10. Probably should write this one down as well, so then you can just do 3, 5, 7, and 9. Number 10 is x minus y is less than 1. So we want to get, again, y by itself. The slope-intercept form that we're looking for is y equals mx plus b. So we want to get the y isolated. It's much easier to graph and see the solutions. So you're still going to have negative y right here. Is less than negative x plus 1. We're going to keep it in this format right here. Divide everything by negative 1. So you get y, and you've got to switch this around to greater than because you're dividing both sides by a negative. That's going to be a positive x, and that's going to be a negative 1. Now you draw your x and y axis. I forgot on this one. Label y-axis and x-axis. This is your y-axis to your x-axis. This point right here is called the y-intercept. And it's 0.0, whatever that number is, so 0, negative 1. It's a free point for us. 0, negative 1 is down here. So we can actually start our graph at that point. In front of your x right now is a 1, and you could make it a fraction, so 1 over 1. That represents your slope, your rise number and your run number. You're rising 1 and running 1. So you're going up 1 and going over 1. Going up 1 and going over 1. And you can do as many times as you want to, and it will make a straight line. Actually, you might want to erase that line for a second, because this does not have an equals underneath. It just has a greater than. So you're actually going to make yourself a dotted line. The answers do not include this line right here. So it's a dotted line, and it's greater than, so you're going to shade the higher side. Greater than sign. What that tells me is that this 0, 0 point right here is a right answer. So if I went back to my original equation and put 0 minus 0 is less than 1, it should be true. And 0 is less than 1, so that does check. So that's how you're going to do page 138. 139, you've got two equations that you have to graph on the same graph. So I'll start with number 19 for you. 19 says y is less than or equal to 2, and y is greater than or equal to x. Okay, so this one only has a y value. So that's an easy one to graph because it's never going to touch the x-axis. It's only going to touch the y-axis at 2. So right there, and again, it's going to go straight across, but it never touches the x-axis. And it's a solid line because we have the equals underneath, and it's going to be less than 2. So all of these numbers down here are more numbers. That means 0, 0 is the right answer. And if you put a 0 in here, 0 is less than 2, so yeah, 0, 0 does work. Now y equals x, or is greater than or equal to x, it's a little different. You could put plus 0 here if you want to get it in slope-intercept form, and you can see that the 0 point, 0, 0 point is one of my starting point right here. It's my free point. My slope again is 1 over 1. So you're going to go from that point up 1 and over 1. Up 1 and over 1. Up 1 and over 1. You can do as many times as you want to. And again, it has the equals underneath, so you are going to make it a solid line. That's right through there. Yeah, this one says greater than, so you're going to shade the higher numbers. Now you're going to see an area where there's double shaded, where it's overlapping. And that's in this area right here. These are all the right answer for both equations. This area right in here, this kind of triangular shape, that's the symbol, or that's the picture where all the right answers would be for our equations, and 0, 0 is part of that. 0, 0 works here, and 0, 0 works here. 0 is greater than or equal to 0. It's equal. So that would be a picture of the graph. So on 19 through 29, you're going to be making one graph of two lines, two shadings, and show where the double shaded area is. And then you move to page 447. You can pause the video and work on all those problems, and then restart the video later after you finish those to get the review. And I'll start with number 1, and it's a system of 3 equations this time. Number 1 says x plus y minus 3z equals 10. And y plus z equals 12. And z equals negative 2. Now, if they're in this format, it's kind of like a triangular format. Let me show you a little better. So z equals negative 2. So you kind of see the triangular shape here. So you could almost draw a triangle around this. That's the shape that one is. And the first 6 are all kind of in that shape where they're much easier to solve because you've already been given z. So z, you're just going to plug right back into the second equation. And you're going to get y plus negative 2 equals 12. You're going to add 2 to both sides. So you're going to get y equals 14. And now that you know what z is and you know what y is, you can plug it back into the original equation. So you get x plus y is 14 minus 3 times z is negative 2 equals 10. X plus 14 plus 6 equals 10. 14 and 6 is 20. X plus 20 equals 10. Subtract 20, you're going to get x equals negative 10. So you just found that x is 10, negative, the y is 14, and the z is negative 2. You need to put it in the format of x, y, z. So that would be how you're going to solve 1 through 6. 7, they're not going to be in this format. So we need to do something a little different. Let me show you 7. Number 7, you got 2x minus y minus z equals 2. We got x minus 5y plus 3z equals 13. And in number 7, the third equation is negative 2x minus 2y plus z equals negative 2. All three equations have all their terms. So here's what you want to do. You want to combine 1 and 2 first. Then you want to combine 3 and 4. No, 1 and 3. So the first thing you want to do is 1 and 2, and then you want to combine 1 and 3. I'll show you how to do that. So we're going to put these two together. You want to get one variable to eliminate. So right now the x is a 2x and this is an x, so let's multiply everything by negative 2. And what that will do is make that a negative 2x and it will cancel out with this one. So I'm going to bring the first one over, 2x minus y minus z equals 2. And then we'll multiply here, we're going to get negative 2x plus 10y, because negative times negative is positive, minus 6z equals 46. You're going to combine those cancel out, you get 9y minus 7z equals 48 when you combine all those. You know what, I messed up. Sorry, hold on. This is 13 times 2 is 26. So let me fix that. Sorry. For some reason I had a 4 in my head. That's 26, so that makes this 28 down here. So it just didn't feel right. Alright, so that's combining 1 and 2 together. Now we're going to combine 1 and 3. And we don't have to multiply anything because 2x and negative 2x are already going to cancel out. So you're going to get, combining a negative y and a negative 2y will give you a negative 3y. A negative z and a positive z will cancel out, so you don't have any z's. And you get let's see, 2 and negative 2, those cancel out also. And you're going to get 0 there also. So basically you're going to get negative 3y equals 0. Now if the z's had not canceled out, you could have just now eliminated one of these two and you would have solved for z. In this case I don't have to eliminate because the z's are already canceling in here. So divide by negative 3 and you're going to get y equals 0. So there's one solution. Take that 0 for y, plug it back up into this equation where that just had y and z. So 9 times 0 minus 7z, 7z, not 2z, sorry, equals 28. 9 times 0 is just 0, so divide by negative 7, you get y equals negative 4. Now you have y, and you, z is negative 4. And I'm just I'm not with it right now, sorry guys. Z right here. So now you have y is 0, you have z is negative 4. Let's plug it back into the original equation. So let's take, we have 2x minus y, now y was 0, so minus 0, minus z, so minus negative 4 equals 2. 0 you don't need, but these are going to make pluses, so you're going to need to subtract 4 on both sides. So you get 2x equals negative 2, divide by 2, x equals negative 1. So you're going to put it in the right order, negative 1, 0, and negative 4. That would be your 7. So you're going to need to combine 1 and 2 to get an answer. Combine 1 and 3 to get an answer. Try to eliminate a variable from there and then solve for one of them. That's 7th variable